So, thanks for that introduction, David. Yes, I'm Sam Stagg. I'm VP of Engineering at Pusher. And today I'm going to just be telling you a short story about living with your early technical decisions as a startup. More specifically, I'm going to be talking about Great. More specifically, I'm going to be talking about how we built and scaled our platform to billions of real-time connections with 5 engineers and 2 broken technologies. Why we changed and how we did it. And the story starts in 2010. Now, 2010 might seem like yesterday to some of you, but actually it was 7 years ago. And just to show the passage of time, I had hair 7 years ago. And the big story of 2010 for developers was WebSockets. Now, WebSockets had just been introduced previously to that. WebSockets make it easy to push data through connections to end users without having to refresh the page on a web application. And Pusher was the first company to make this easy to implement with just a couple of lines of code on the server and a few lines of code on the client. And we started out solving a problem at our founder Max's agency, and we grew, realized that it was a successful product, started to sell it. Over time, we managed to get plenty of big customers on board, like some of these guys, and we also managed to take the WebSocket solution and build it into something that was reliable, resilient, supported 150,000 developers, and now we send over 200 billion messages every month. Now, the Pusher architecture is actually pretty straightforward. It fits onto a Post-it note. That's what I've done here with this great drawing. Customers connect to our API, and they send messages through channels to their end users who connect to our platform via WebSockets. We handle all the challenges of keeping that platform up and running, and we make it easy to scale to potentially millions of connected clients at the end. Now, I just have a show of hands now. Who's heard of Nodejs? Great, so keep your hand in the air if you've heard of Event Machine. That's good, apart from the people who know at the back, but a few people put their hands down there. But actually, this is from the Node.js About page. Node was influenced by Event Machine. Event Machine is an event-driven framework for Ruby that makes it easy to add event-driven programming loops to Ruby code. And if you were a technology team in 2010, Event Machine was the obvious choice to pick, and we use it across our stack. Now, the thing about Event Machine is that it's kind of like the Velvet Underground of event-driven programming frameworks. It's really influential, but it was really inaccessible, and no one used it. So we were kind of making this original decision. It made a lot of sense in 2010, but over time, we never actually had time to revisit this original decision, and we're still living with that. Now we still use Event Machine across our stack, and this wasn't actually too bad in the end. You know, we're still using it. We still managed to scale it to our use case. And at the beginning of our journey, we were far more worried about problems of scale and survival, just keeping ourselves going, earning revenue off each new customer we got. And we were far more worried about something we called the domino cascade of death, which was the problem of a cascading failure in a component causing the whole platform to fall over. And we had to really work harder in our early days to fix these kind of problems with the platform. In fact, when we got ESPN signed up in 2012, we needed a 3-month lead time to be able to support their requirements for 2 million concurrent connections. So this is kind of the story of our early 3 years. We call this the survival epoch as a business. We were just keeping ourselves going with a hand-to-mouth existence, and specifically, we didn't have the revenue to grow our engineering team. And in fact, we managed to support our customers all over the world doing all these amazing things with just 5 engineers for most of these 3 years. And that was actually all right, because we offloaded a lot of the complexity of our platform to battle-tested technologies based on sound computer science principles. And it meant we could focus on building a great product differentiator, which was an easy-to-use API that just worked for our customers. And this takes me back to the second technology I'm going to talk about, which is Redis. Now, Redis is primarily known as a key value store, but we use it in our platform as a pub/sub message bus. In fact, it's our core message bus within each cluster that we deploy. And I should caveat this, make sure it's very clear. Redis is awesome. We love Redis. We're really happy to use it, and it's basically one of the core pieces of our success. However, we built our product with Redis because we wanted to focus on the product differentiator, which was this easy-to-use API. And when you pick Redis, you are making a decision, and it's a very clear trade-off, that speed and performance are more important to you than fault tolerance and resilience and reliability and things like that. And we knew about that, and that was fine because at the start, that wasn't so much of a concern for us. But over time, as we got these customers like ESPN, we actually had to invest a considerable amount of engineering effort in building the infrastructure around Redis to actually help us to support things like failovers and add some resilience to the platform. But it all worked, and in the end, when it got to the beginning of 2016, we were in a really great place. We had a great brand, we had loyal customers, we had the ability now for an engineer to deploy one of those ESPN-sized clusters. And rather than it taking 3 months, it took 2 commands and a config file change. So we were pretty happy with everything. And as a business, we were now able to sell this resilient API we built. And we were getting lots of feedback from customers, people saying, yeah, this is great, it'd be great if you did this, or if you did that, or could you do this for me? Now, this is where things got a bit difficult, because we'd made these early technical decisions to support one use case. And fundamentally, our products and platform were entirely focused on fixing this issue, or solving this one problem of getting data to large numbers of connected clients. Now, a lot of this was tied up in the several decisions that we made earlier on. The technology ones were part of it, but also our development model was focused on this idea of 5 engineers who were all really hard to hire, really hard to replace. They were all complete subject matter experts. And the code they were working on was really tightly coupled, so they couldn't share responsibilities across the platform because they'd be stepping on each other's toes. And it also meant we couldn't just hire 20 engineers because they'd all be working on the same code base and causing problems for each other. Now, in a way, this is what's called technical debt. Now, technical debt is essentially deferring the resolution of technical issues on your platform so that you can focus on building great features. But it's analogous to real debt. And when you have real debt, there's interest payments to be made. There's the responsibility to make sure those things actually get resolved. And if you don't pay off your debt, then it can kill your company. And obviously, we didn't want that to happen. And so we decided to pay off some of the most urgent tranches of technical debt when the bailiffs were knocking at our door. One of those was that we replaced our provisioning system with Ansible. We'd home-rolled our own provisioning system and we replaced it with Ansible. Now, that was a sort of example of the kind of thing we could do, but what we couldn't do is add all these cool new features that our customers were asking us for. And just to make things even more complicated, the platform was still growing. Customers were still increasing their usage of our platform, and we were still signing up more people. We were still driving new sales for the product. And that means it's a bit like changing the thrusters on a rocket ship as it's taking off. And there's a couple more problems there as well. The people who built the original rocket ship are off building another one somewhere else. And the thrusters that you're going to replace your existing thrusters with probably have their own individual quirks as well. So it's not really a good idea. And at this point, some good fortune fell into our laps. One of our lead engineers who had got frustrated with this inability of the team to be able to add new features and actually taken a sabbatical to focus on building a prototype version of a new platform that could solve some of these problems we were having with rapidly responding to customer feedback. He also became a professional esports racing driver, but that's another story. The main changes that he wanted to do was build something that helped us to learn and react quickly to feedback and build new experiments without having to all build on on top of the same code base. And that all worked pretty well. We managed to get a new platform built, and we started using it to build experiments. And as part of that, we were able to switch out some of the technologies. Now, what it's important to say is that the product was still really useful. People were still enjoying using it. And it wasn't just about taking some of this old technology, the bad decisions we made earlier with Redis and Event Machine, and replacing that with new technology. That wasn't just about building some cool new stuff. It was because we wanted to be able to add value to our company and to our customers' experience of our products. And so we did manage to, of course, make some cool changes as well. We managed to switch from Ruby to Go, and we started using Kubernetes as the backbone of our infrastructure, and we're also using Worker for continuous delivery. Now, all of those technologies wouldn't have been possible 2 years ago, let alone 7. So it was an opportunity to improve and learn from the scalable web architecture movement that's built up over the past 7 years. At this point, I think you'd be justified in asking, did it work? Well, we're very happy with the results of this personally. For our engineering team, it certainly helped us to learn a lot about building a new scalable web platform, and it's also helped us to build 3 new beta products. Now, bear in mind, we were finding it hard to build 1 previously, so now we're getting 3, which is pretty cool. As an example, those 3 things are adding history to our pub sub message bus, which wasn't possible before, making it really easy for people to build chat applications, which we know is a use case our customers want. And finally, we've kind of experimented with making it really easy for people to build a collaborative text editor with just a couple of lines of client-side code. And we handle all the back-end manipulation of the data that's required for that. So in our minds, it's been a pretty good success, and yet we still managed to keep the old platform running with a sort of skeleton team keeping it going. And one of the things we found is that the number of incidents on our old platform went down because we weren't working on it quite so much, which is kind of a lesson for us as well. And finally, we did manage to grow our team from 5 people to 25, and here they are. Now, the best thing about hiring more people is not just that we have a 5-a-side football team now. It's that we can also build independently because we've managed to parallelize our development effort across different components. And that was really important for us to be able to support that. So, to finish off, just to summarize the story I've told you. As a company, we started out, we built a really successful product. We did make some decisions initially that possibly with the benefit of hindsight were mistakes, but actually that didn't matter. We still managed to build a rocket ship. We still managed to make a product that's growing, that's still driving revenue, and still customers really enjoy using. However, there does come a point where you need to think about changing. And for us, that was when our customers' needs started to evolve, and we needed to evolve with them. Thanks very much. Any questions?
Hello, there we go, all good. So when you're building this out, and obviously you first start getting your kind of clients on, and as you said, you start getting to the scale where it kind of becomes quite apparent you've got quite a lot of tech debt on the go.
Yep.
What are the thoughts? I mean, I suppose generally for engineering talent, it's more of a case of we need to build this right, perfect first time. There's no room for error. We've got to get this right from the very start. Let's spend months and months planning this feature to make sure we do it absolutely perfect and future-proof it. At what stage did you kind of have to say to your team, let's stop there, let's make sure that we are going to keep on pushing these things out, getting new features in there, and then we can revisit this tech debt later on? When is it that you say there is that hard stop point?
I think it's when you realize that, I mean, you're talking about the first platform here, not the second, because there's a second system effect where the temptation is to try and make the second one completely perfect as well. But actually, for us, the pressure was never there to resolve that initial tech debt, because we'd made, I think the point is, if you make your first decisions based on reasonably sound principles, then hopefully you don't have to revisit that. If it turns out the principles were unsound, that's probably the time that you need to start thinking about it. So it's kind of revisiting those original decisions, why you made them, what the principles were behind them, and making sure that you actually resolve the tension between those and what you've delivered as a first instance. And that was kind of what we found. We never needed to do that because we'd made the technology choices we made sense, but they just didn't make sense for when we grew as well.
More questions? No? Thank you, Sam.
Great, thanks very much.